Okay, let us start the next exercise 1.2. So what we are going to study first in this exercise is finite and infinite sets. So as the name suggests, a finite set is a set which has got definite number of elements inside it, right? And an infinite set is a set where the number is not definite, right? For example, if I say that there is a set A which has got elements like 1 2 3 4 5. All right, there is a set B which has got elements A E I O U, and then there is a set C which has got a set of natural numbers, right? So if I write it in set builder form, I'll write X such that X is X belongs to natural numbers, let us say. Okay, so now when I talk about natural numbers are 1 2 3 4 5, and it continues. You cannot count them because these are infinite such numbers which are natural numbers. When if you suggest me the biggest natural number, what I'll do is I'll add 1 in it and you'll get the next. So you cannot stop anywhere. So this type of set is an infinite set. Infinite set. Now I did not write it in the roster form first because I can write it in roster form, but there is a special rule. Now if I want to write it in roster form, what I'll do is I'll write the natural number, first natural number, second natural number, third natural number. I'll write some of the natural numbers which will show me the pattern on which I am writing these numbers. So the next number, you know what will be the next number. I have written 1 2 3. So the next number you can predict with certainty that it is 4, right? And then you cannot write all the numbers in this set, right? So what you will do is you will, after a certain time, you will write dot dot dot, okay, which will mean that it continues like this. So 1 2 3 4, and the next number will be 5 6 7, and so on. In these sets A and B, we have got fixed number of elements, right? So if I ask you how many elements are there in this set, and the way of writing it mathematically is number of elements in set A is equal to 1 2 3 4 5. So number of elements in set A is 5. Number of elements in set B, I have written all the vowels here, so it is equal to 5. But if I ask you number of elements in set C, number of elements in set C, can you count these numbers or can you tell me a definite number? You cannot, right? So it cannot be defined, or you can say infinite, right? So this is about finite and infinite sets. But when if let us say I ask you something, if I ask you, let us say set A is a set of, let us say X is such that X is the number of men living on Earth, living on planet Earth. Now the question you need to ask yourself is whether the number of elements of this set can be counted. Now I am not asking you to give me a fixed number here, but I am asking a question: can it be counted? Can it be counted, and can you reach at a fixed number? You do not have to count it yourself, but can it be counted by some mechanism or something? Yes, it can be counted. There is a fixed number of men at a particular time living on Earth, so it can be counted. So is it a finite set or infinite set? Obviously it is a finite set. Obviously it is a finite set, because yes, you may count the men living on Earth, because there is something called census, right? It is done every 10th year in India, where we count our population. Okay, so it is possible that we can count. There is a big system involved in counting, that is another thing. Now if I ask you that there is a set A which is a set of a set of prime numbers. Set of prime numbers. Now the smallest prime that you can write is 2, right? The next prime number is 3, the next is 5, next is 7, right? You can keep on writing these prime numbers, right? Okay, after this you will have, even if you write the largest prime that you know, okay, if you write the largest prime that you know, I'll write the next prime, okay. So you cannot exhaust these numbers on this board, right? You will not be able to write all the prime numbers on this board. So what is this set? A set of prime numbers. It is an infinite set. It is an infinite set. All right. So we have studied that infinite sets are usually written in roster form. Let us say set of natural numbers with dot 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 inside it, right? Which shows the continuity of these numbers in a particular pattern. For example, 1, 2, 3, 4, and next number will be 5. But all the infinite sets cannot be written in roster form. Cannot be written in roster form. Let me give you an example. A set of real numbers. I told about it in the introduction of first chapter also, first exercise also. So a set of real numbers, let us say you got this real number line, right? 0, 1, 2, and so on. Then there is -1, -2, and so on the negative side. So there are infinite numbers between any two numbers on this number line, right? We know this, because between 0 and 1 there will be 1/2 here, and between these two there will be 1/4. Between 0 and 1/4 there will be infinite numbers. Okay, so if I want to write these numbers in the form of a set in roster form, I will not be able to write all these numbers. For that, I introduced one more bracket. I told you that you can write this set of real numbers like this. These open brackets and then -infinity to infinity, which doesn't include these infinity, right? So it includes every other real number, but it doesn't include this -infinity and infinity inside this solution. Okay, so it includes every number which is between -infinity and infinity. Infinity, we have already discussed, is not a number. It is just an idea of a very, 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 very big number. Okay, so it is just a notion. It is not a number. Obviously, it is not a real number. And about finite sets, if I say that there is a set in which I do not have any number written, so these sets are known as null sets or empty sets. Now, what does it mean? For example, let us say I have got this x squared plus 1 equal to 0. Okay, x squared plus 1 is equal to 0, and I want you to find the solutions of this equation where x is a real number, right? So x squared plus 1 equal to 0, I need to find its solutions where x is a real number. Can there be any real x for which x squared plus 1 is equal to 0? No, because if I take x as some negative number, its square will become a positive number, and plus 1 is equal to 0. It cannot be equal to 0, right? So if I take x as equal to 0, right, which is the least value of x square, the least x square can be is 0. So if I take its least value, even then it will not be equal to 0. So 0 plus 1 will be greater than 0. So what are the solutions of this equation where x is a real number? You will say there is no solution. There is no solution. Or you can say in form of the set, you can say that there is no solution. Like this solution set is an empty set, right? You will write it like this. Because in mathematics, no solution is also a solution, right? Because for this equation, I did not have any solution in real numbers. So there is no solution And this is a perfect answer in mathematics, that this equation hasn't got any solution, or the solution set for this equation is an empty set. Okay, or in other scenario, if I say that x is less than 5 and x is greater than 7, right, and find me the solution. So write the solution set for it. You will say empty set, because there can be no x such that it is less than 5 and greater than 7 at the same time, right? So it is not possible. Let us take first example based on this fact. State which of the following sets are finite or infinite, right? Now, as we said, the question we need to ask ourselves, can the solutions or can the elements be counted or not? So let us first of all try and write the elements of this set, right, in roster form and see whether this is finite or infinite. Okay, so x is a natural number, all right, and x satisfies this equation. So x minus 1 into x minus 2 is equal to 0. That means x will be either 1 or 2, and x belongs to natural numbers. So yes, this set can be written in roster form like 1 comma 2. So it is a finite set because I can count these numbers. It is the number of elements in this set is 2. So this is a finite set. Finite set. Now look at the next set. X squared is equal to 4 and x belongs to natural number. Now if I consider only this equation, x squared is equal to 4, then this will give me x equal to plus minus 2. Now there is another condition that is given, x belongs to natural number. So the solution set for this will be, because it is a natural number, so out of this minus 2 and 2, this will be invalid solution, so only solution is 2. So this set written in roster form is this. So number of elements is 1. So this is a finite set. Finite. Look at this. X is a natural number and this equation is, x should satisfy this equation. 2x minus 1 is equal to 0. So 2x minus 1 equal to 0 will give me only one solution, that is x equal to 1 by 2. Now it has to satisfy other condition, which is x should belong to natural numbers. So now you see, x should belong to natural number and this equation gives me x equal to 1 by 2. So there is no such x which is a natural number and is equal to 1 by 2, right? So the number of elements in this set will be 0. So there is no such x which satisfies both these conditions simultaneously, because there is an and here. X should be a natural number and x should satisfy this. There is no such x. So we have got 0 solutions. So we will write an empty set. An empty set is also a finite set, right? Look at this. X is a natural number and x is prime, right? So all the prime numbers, let me write some of the prime numbers for you. 2, 3, 5, 7 and so on. If I keep on writing these prime numbers, all these prime numbers are natural numbers also. So can you count these numbers? No, right? You cannot count these numbers. So this is an infinite set. Okay, x belongs to natural numbers and x is odd. So this will be a set of natural numbers which are odd. So it will be like this: 1, 3, 5, 7 and so on. This is also an infinite set, because if you cannot give me the biggest odd number, let us say odd natural number, if you give me a number, very big odd natural number, then what I'll do is I'll add 2 in it and I'll find the next number, then I'll add 2 in it, I'll find the next number. So this is infinite. This set is infinite. All right, now the next thing that we are going to study is equal sets. Equal sets. Let us say I've got two sets. One is set A, which is 1, 2, 3, 4. These are the elements, and there is set B, which has got elements 2, 1, 3, 4. Now I need to check whether these are equal sets or not, right? So I'll look at the elements. If there is an element in A, whether this element is present in B, yes. 2 is present in A, so 2 is present in B, yes. 3, 3, 4, 4. So if every element that is present in set A is also present in set B, and vice versa is also true, right? Because there can be a scenario when, let us say, A is 1, 2, 3, 4, and there is another set C which is 1, 2, 3, 4, 5. Okay, now I said that every element of A is present in set B, so it is also present in set C. But when I say vice versa is also true, that every element of set B is present in set A. So vice versa is true for B and A only. C, similarly, 5 is present in C, but it is not present in A. So what will I say about set A and set B? That these are equal sets. What will I say about A and C? These are unequal sets. A is not equal to C, right? So if every element of a set is present in the other set and every element of the other set is present in this set, then we can say that these two sets are equal to each other. Another thing that we need to take care of is that if I've got a set A, let us say 1, 2, 3, 4, and if I've got a set B which is 1, 2, 2, 3, 4. Now every element of set A is present in B? Yes. Every element of set B is present in A? Yes. Right? Because I have written 2 times. Okay. But 2 is present in B and 2 is present in A. It doesn't matter how many times, because repetition does not matter, and the appropriate way of writing a set is without repetition. So set B is nothing but 1, 2, 3, 4. If I ask number of elements in a set, I mean the number of distinct elements. So distinct elements are only 1, 2, 3, and 4. So these two sets are also equal. Okay, so if repetition is there in the set, we just need to check for the elements whether the particular element is present in both the sets or not, and vice versa should also be true. So this was about introduction of equal sets. Let's look at some questions. Find the pair of equal sets, if any, and give reasons. Now out of these A, B, C, D and E, we need to find pair of equal sets. So set A has got only one element, that is 0. What about set C? If I write this set C in roster form, x minus 5 equals 0. So this will give me x equal to 5. So in the roster form I can write it like this, right? And here x is greater than 15 and x is less than 5. Now x is greater than 15 and x is less than 5. Can there be any number, any such number? No. So if I want to write it in roster form, this set, I'll have to write an empty set. This is an empty set. Okay, some of the students may be confused. Is this an empty set, set A? No, it is not an empty set. It has got one element, that is 0. Now this set is an empty set. It hasn't got any element in it, right? What about set D? X square is equal to 25. So that means x can be minus 5 or plus 5. So it has got two elements, minus 5 and plus 5. E, x is an integral positive root of this equation. So integral positive root. So you have to first of all solve this equation, this quadratic equation. To solve this, I'll factorize the middle term and see what are the factors. So x squared minus 5x plus 3x minus 15 equals 0. So now I'll solve it like this. X minus 5 plus 3, x minus 5 equals 0. So x plus 3 into x minus 5 equals 0. Now this should be 0 or this should be 0 for this equation to be equal to 0. So now this will give me x equal to negative 3, or I'll get x equal to 5 from here. And see, x is an integral positive root. So this is not positive. So the only integral positive root is x equal to 5. So if I want to write it in roster form, this can be written as this, because there is only one integral positive root of this equation. This quadratic equation has got only one integral positive root. Now look at these sets and see which pairs of equal sets are there. A is 0. Is there any other set which has got only one element, that is 0? No. Is there any other empty set? No. So set C has got only one element, that is 5, and set E has got only one element, that is 5. So set C is equal to set E. This is for sure. Now set D is not equal to set C or set E, right? Because now, as per definition, every element of set C should be there in set D, right? It is true. But every element of set D is not there in set C, because -5 is not there in C or E. So this is the only pair of equal sets. Okay, let us come to the questions. Which of the following pairs of sets are equal? Justify your answer. X, the set of letters in alloy. So if I want to write it in roster form, I can write it as ALOY. And B, the set of letters in loyal. So B is equal to LOYA. Right? Now, are set X and set B equal? Yes, because A is there in set A is there in set B. L, O, Y. So exactly same elements are present in set X and set B. Now these repetitions doesn't matter, right? Because there L is being repeated in both the sets, but that doesn't matter. So you have to consider only the distinct elements. So there are exactly the same elements in set A and set B. So these are equal sets. Okay, so set X is equal to set B. N is such that n belongs to integers and n is less than or equal to -4. So how do you solve such equations? You should know that n square is less than equal to 4. You can write it as n square minus 4 less than equal to 0. You can further write it as n minus 2 into n plus 2 less than equal to 0. Right? Now, for it to be true, what you do is you draw a number line like this with the critical points. What do you mean by critical points? The points at which this becomes 0. So it becomes 0 at n equal to 2 and n equal to -2. You write it here. Now you see, for the values that lie between -2 and 2, this will be true, right? You put value 0 here, it will be -2 into 2 -4, so it is true. If I put -2, it will be 0, so it is also true. So the solution for this equation, and n is an integer, so -2, -1, 0, 1 and 2. If I want to write set A in roster form, I can write it as -2, -1, 0, 1, 2, because all these values will satisfy this equation, this inequation, and these are all integers. Okay, if somebody doesn't understand this method, because this is a product of two things and it is negative or equal to 0. Product of two things can be negative when these two things are of opposite signs, right? So x will be greater than -2 and less than 2, right? These two product of these two things is negative, right? So what you do is, if you put anything greater than 2, what will happen is this bracket will become positive and this bracket will also become positive. Then it will not be the solution of this. If you put anything lesser than -2, let us put -3. If I put -3 here, this bracket will be negative and this bracket will be negative. So their product will become positive. So these brackets have to be of opposite signs, and these will be of opposite signs only between -2 and 2. Right? So this is how you can judge. You can find the answer. So this is your answer for this set A. Now look at set B. X belongs to real numbers and is a solution of this quadratic equation. Now just by looking at it, I can say that these two sets will not be equal. Why? Because this is a quadratic equation and it can have maximum two solutions, right? It can have maximum two solutions, quadratic equation, right? So if you factorize it, you can factorize it like this, right? And if you factorize it further, you will know that it has got two solutions, 1 and 2. So if I want to write this set B in roster form, I'll write it as 1, 2. Now these are not equal sets. Okay, look at this. Which of the following are examples of null set or empty set? Right? Set of odd natural numbers divisible by 3. So it is obviously a null set. Why? Because there is no odd natural number that is divisible by 2. If a number is divisible by 2, obviously it will be an even number, right? That is the definition of even numbers. So there is no such odd number, so it is a null set. Set of even prime numbers, it is not a null set because there is an even number which is also prime. So set of even prime numbers is this set which has got one element, so it is not a null set. So the first one is a null set, second one is not a null set. Look at this. X is a natural number which is less than 5 and greater than 7 and greater than 7. It cannot be possible that there is a number which is less than 5 and greater than 7. So there is no such number. Or another way of saying this is solution set is a null set. Y is a point common to any two parallel lines. What is the definition of parallel lines? That they do not have any common point. So there can be no such y. So it is a null set. Let us look at the next question. Which of the following sets are finite or infinite? The set of months of a year, it is a finite set, right? You can very well count the months of a year. There are 12 months and you can name them also. This is 1, 2, 3 and so on. So it is an infinite set. This is set of natural numbers. You can keep on writing the natural numbers. You will never stop. This is obviously a finite set. You can count the number of elements there in this set. Okay. So it is 1 to 100 only. So there are 100 elements in this set. This is a finite set. The set of positive integers greater than 100. Greater than 100, I'll start with 101, 102, 103 and so on. I can keep on writing the positive integers after 100, greater than 100. So this is an infinite set. Infinite set. The set of prime numbers less than 99. So yes, it can be easily counted, right? First prime will be 2, 3. Okay, so in this way you can easily count these. So it is a finite set. Next, state whether each of the following is a finite or infinite set. Set of lines which are parallel to x-axis. So this is x-axis, let us say. You can have infinite number of parallel lines to it. Okay, but you can let us say I give you a question, another question. A set of lines which are parallel to x-axis and pass through a point 2, 3. Now this is a fixed line because let us say this is 2 and this is 3. This is the point that I'm talking about. Now I have fixed a line. So there will be only one line in that case which will be parallel to x-axis and pass through this point. So if the question is twisted in this way, then it will become a finite set. Otherwise the question in this original form is the original form of this question will give me an infinite set. This is an infinite set. Okay, but you should be careful about the twist in this question. So you should read every question independently, right? You should not memorize a question. The set of letters in English alphabet. We know these are fixed number of alphabets, A, B, C, D, right, up to Z. So there are 26 letters in English alphabet. This is fixed, so it is finite set. The set of numbers which are multiples of 5, it is an infinite set, because you can keep on writing the multiples like this: 5, 10, 15, 20, 25, and so on. This is an infinite set. A set of animals living on the earth. Now this is a finite set, right? Because at any particular time there is a finite number of animals living on the earth, right? Whether we are able to count them, we can count them, okay? If we employ a system like big system to count these, we can count these, okay? It may be difficult, but these are countable. So it is a fixed number that at any particular time of the animals living on earth. So it is a finite set. The set of circles passing through the origin. Now this is one point. You can have infinite number of circles passing through this point. Infinite number of circles can pass through this point, okay? So this is an infinite set. But if the question is formed like, if you have got 2 points and then you are a set of circles passing through these 2 points, let us say 0, 0 and 1, 1. Now how many circles will you have? 1. There can be another circle like this. There can be another circle like this. You will still have infinite number of circles passing through. Now if you are given 3 fixed points and then you are asked whether this will be a finite set or infinite set, now there will be only one circle that can pass through 3 distinct non-collinear points, right? So there can only be one circle passing through it. We have done this question in geometry, right? So you should be aware of the question. Now there is only one point, so there are infinite number of circles passing through this single point. Even if 2 points are given, there will be infinite number. But if 3 points are given and these are non-collinear, so we will say there are infinite, there is only one circle that passes through. There is a unique circle that passes through it, and that will be finite. But this question has got this answer infinite. In the following, state whether A is equal to B. So we just need to see whether every element of A is present in B. So yes, it is present. Order does not matter. Okay, element should be present. A is present, A is present. B is there, it is there. And vice versa should also be true. Every element of B should be there in A. So it is true for this first part. So A is equal to B. Every element of A should be in B. 4, yes. 8, yes. 12, no. So obviously A is not equal to B. We don't have to check vice versa, because 12 is present in A, but it's not present in B. It tells me that A is not equal to B. Similarly here, A has got values 2, 4, 6, 8, 10. X is positive even integer and less than or equal to 10. So what are positive even integers? 2, 4, 6, 8. It should be less than equal 10. So 10. And this is what we have got in A. So A is equal to B. Exactly the same elements in both the sets. So these are equal sets. X is a multiple of 10. So what does it mean? This set has got element 10, 20, 30, 40 and so on. But in set B, you see there is 10, 15, 20, 25. So 15 is there in B, but it is not there in A. So obviously A and B are unequal. Are the following pair of sets equal? A is 2, 3, B, X is a solution of this quadratic equation. So now this quadratic equation can be solved by factorizing. 3x plus 2x plus 6 equals 0. So here I'll have x plus 3 and x plus 2 equals 0. So the solution of this quadratic is minus 2 comma minus 3. So in roster form I can write it as minus 2 comma minus 3. Okay, so these are unequal sets. These are not equal. X is a letter of the word follow. Y is a letter of the word wolf. So if I want to write it in roster form, how will I write? F O L, and then I will not write this L, not write this O, because these are being repeated, and then I'll write W. Now you check whether and set B can be written as WOLF. Now you check, these are exactly same elements written in A and written in set B. The order we know doesn't matter, right? So obviously these are equal sets. Set A is equal to set B in this question. In this, set A was not equal to set B. From the sets given below, select equal sets. So I'll look at every set and see which set is equal to which set. So first let us look at A. 2, 4, 8, 12. Exactly the same element we are looking for. We do not have exactly same elements in any of these sets. 1, 2, 3, 4. 1, 2, 3, 4. So A and D has B and D has got equal. B and D are equal sets because these have got exactly the same elements. Look at C. 4, 8, 12, 14. So it hasn't got like C has got 4, 8, 12, 14. No other set has got the same elements. Minus 1, 1, 1, minus 1. So E and G have got exactly the same elements. Order in which they are written doesn't matter. F 0, A, and this is 0, 1. So obviously value of A we do not know, so these are also not equal. If let us say this is 0, 1, then E will be equal to F will be equal to H, but in this case A is unknown, this is some other constant, so we don't know whether it is equal to H or not. Then we will say these are only two pairs which are equal to each other. Okay,